Hi there, I'm Ross, and this is Reinforced. You might have seen a video I posted on LinkedIn about this part right here. Since posting, I received tons of questions about the best practices for modeling knurls in the 3D printing process. So I'm here to teach you. Let's dive into it. Most of you watching that come from a manufacturing background probably already know what knurling is. But for those of you that don't, allow me to define it. Knurling is a manufacturing operation typically performed on a lathe to create a pattern by making a set of unique cuts that adds a texture to the surface of an object, such as the parts on this table right here. One of the most common use cases for knurling is to add grippage to an object. You've probably seen it on a series of parts in your machine shop, such as this die wrench handle or this threaded knob. So why would I want to 3D print knurls over creating them with traditional manufacturing? Traditional knurling requires specialized cutting tools and a unique skill set to do this operation correctly. But the barriers to entry with 3D printing are significantly lower. And it starts in CAD. We're going to be adding some knurls to the lower section of this keyed grip right here, so it's more ergonomically friendly to the technicians that use this tool every single day. This keyed grip is a great application for the Metal X because it's low volume, trivially complex in its design, and has certain custom features like this tool number and this mistake-proof emboss. If I wanted to incorporate these knurlings, it would require two different manufacturing operations, milled on a CNC and then turned on a lathe. Alternatively, the Metal X can hit all these design features in a single manufacturing process. Today, we're going to use Fusion 360 as our CAD tool. Let's jump into it. Now that we're in Fusion 360, I have the bulk of my design already made, and we're going to add the knurling. I first want to define a plane that will show where the endpoint of my knurling pattern should go. We're going to set this to 30 millimeters above the bottom. Next, we're going to use the coil tool. I'm going to start the sketch at the top portion and just kind of roughly sketch the diameter. Because right here, we can define it further as 25 millimeters. We'll also set the height to 30 millimeters. Next, we want to set the revolutions. And you're going to have a little bit of design freedom here. It really depends on the diameter and height of the sections that you're adding this pattern to. And in this case, a quarter revolution looks appropriate. For the section, Fusion defaulted to triangular inner. And that's what we'll use, a triangular cut. The section size is an important thing with 3D printing. And I typically use 1 millimeter depth because it requires no post-processing or advanced settings. If you need additional grippage, you can increase the depth up to 2 millimeters. However, at this depth, supports will be auto-generated in the model. You can use our override tools in Eiger to remove these supports prior to printing and avoid any extra post-processing. For more information on how to utilize support overrides, click the link up in the corner. Now that we have this generated and it all looks good to me, I will confirm and make that cut. The second step is to mirror this cut. So I'm going to select the mirror tool. I will select the two faces of the cut. And then I will select my symmetry plane, which is located right here. It kind of creates this neat V pattern. The last step is to do a circular pattern. This time I have 4 faces to select. And my axis of symmetry is just the center axis of the cylinder. Now we have a little bit of design freedom here. The number of instances that we replicate. If we go a low number like 15, the size of these diamonds is going to be larger and the density will be more sparse. If we go higher, like 50, it will have better grippage, but we need to consider the limitations of printing. And something you want to consider here is that the width of these diamonds should be no smaller than 0.4 millimeters. In this case, I'm going to use a balance and select as 30 millimeters. And of course, this is dependent on the diameter and height that we used, so you can digitally iterate and decide what is ideal for your use case. I will confirm it and hit OK. Sometimes this can take a few seconds as it's doing a lot of math in the background to generate this very unique pattern. And there you have it. We're now ready to export this as an STL file, slice it in our software, and begin printing. Let's recap what we just learned. You can use just about any type of CAD tool to model knurls that can be 3D printed in 3 simple operations. First, we use a coil with a 1mm triangular depth and cut that into the part. We then mirror that across a symmetry plane to create an upside down V shape. And finally, we circular pattern that V shape with a certain number of instances dependent on your use case and how sparse or dense you want the pattern to be. Hope you found this helpful and are ready to start incorporating Knurl into your 3D printing designs. If you enjoyed this content, make sure to hit that like button and subscribe to Markforged for more content just like this. Thanks for watching and happy printing.